This video is just going to quickly talk through what's called the vertical line test. Which is just a simple way to look at a graph and determine quickly whether or not it's a function. And what I'm going to do, I'm going to plot 2 points on this circle. And I'm choosing the point -1, -3, and I'm choosing the point -1, +3. Let's go back and think about the things that we've already studied this week regarding functions. If I have x values and y values, and I have an x value of -1 and y values of +3 and -3, I can map this x value to 2 different y values, which already tells me that it's not a function. So visually, the way to support that thought, when I have a graph, if I can plot 2 points and connect those points to make a straight line, a vertical line, then I assume that this graph is not a function. And that's just a visual support for the thought that if I have an x value that repeats with two different y values, this is considered not a function. And the line is called the vertical line test. So for this weekend, I just want you to look at the graphs and determine visually whether or not they're a function, yes or no, based solely on this vertical line test. So if you can draw a vertical line through the graph and intersect it in 2 or more places, then it's considered not a function. And then I want to show you how to write the domain and the range in interval notation, and then using the notation that we practiced in class a little bit. So let's go down and look at number 4 for notation purposes. So the domain for number 4, remember domain's associated with x, range is associated with y. My domain, this graph looks like it's growing in the direction of infinity in both directions on the x-axis without end. So I would have to assume that the domain here is all real numbers, all reals. My range, on the other hand, which is my vertical, the vertical area that it's taking up on the graph, I'm starting up here at 1, 2, 3, 4. I'm starting at the point 0, 4. And this graph is growing away from +4 on the y-axis. So we practiced this in class. I'm going to use the notation y such that y is less than or equal to 4. And this notation with the brace and the line, this line stands for the words such that. And this is universal math notation. So this is just a notation. And I'm representing the same thing in a few different ways. So visually looking at this graph, would this graph represent a function? Well, if I start doing the vertical line test, it looks like I'm not going to be able to intersect this graph in more than one spot at a time with a vertical line. So I would say yes, this is a function based on the vertical line test. And now I would like to give you an alternate way to write the domain and the range. And I'm going to use what's called interval notation. And it's just written in my handwriting. So interval notation, let's see, first of all, let's do all reals, all real numbers. If I'm saying that, like the graph that we just did above, the domain was all real numbers. So that's really thinking I have negative infinity going all the way to positive infinity. When I'm looking at, look at the symbols that I've written over here under interval notation. Here I have the hard brackets. This means that my endpoint is included. An open bracket means the endpoint is not included. And the combination brackets would mean that one endpoint's included, bounded, the other is not included, or it's unbounded. So the way that I would represent all reals as being my domain or my range, which means I'm growing endlessly in the direction of both positive and negative infinity, I can't bound infinity. So I would have to just use open braces and say that I'm including negative infinity all the way up to positive infinity with the open braces because I cannot include that endpoint. I think the other example that we had was y such that y is going to be less than or equal to positive 4, the graph that we just did. I would like to give you an interpretation for writing this in interval notation. So we need to go back and look at the graph, but it was growing in the direction of negative infinity. So I would start with negative infinity all the way up to 4. Since I can't bind infinity, I can't bound it up, I have to use the curved open brace, but 4 was a hard endpoint included on that graph. So this would be an alternate way to represent the range, starting at positive 4 and then growing away from positive 4 endlessly in the direction of negative infinity. Let's look at a few that I can get into view here. Okay, graph number 7. Graph number 7. Endlessly, it looks like on the x-axis, there's no limit to what could happen. So my domain really would be all real numbers. Or in the world of interval notation, I would have the curved bracket. I would have negative infinity all the way to positive infinity with the curved bracket. My range, on the other hand, this graph is oscillating between negative 3 and positive 2. So with interval notation, those will be hard bracket included endpoints. I will put the lowest value first, the highest value second, and use the hard brackets. Or I have the choice to do the notation. I would have y such that, and then I would need to do, and I'm having a problem with the smartboard, so I'm just going to cross this out. The other alternate notation would be y such that negative 3 is less than or equal to y, which is less than or equal to 2. So I'm just giving you alternatives for representing the same information. And looking at a graph like number 7, is this a function based on the vertical line test? It doesn't appear that I can draw vertical lines and touch this in more than one spot at a time, so I would say yes, this is a function. And it's pretty easy to look at a graph like number 8 and quickly decide that this is not a function. And I will let you do the interval ranges for the domain and the range on your own for a graph like number 8. And in number 10, the line is down here. And I will let you all figure that out on your own. And number 9 is your vertical line. And I will let you all look at that, and we can discuss this in class on Monday.